Hello everyone, welcome to Wi-Fi Learn. We are seeing the topic in engineering mathematics. In last video, we have seen the topic of properties of determinants. I have left with one more property. We can continue the property and let's see some problems regarding properties of determinants. Okay? I think I already said the book I refer for this topic is Higher Engineering Mathematics, written by B.S. Grewell. It's available in online. I'll put the link in the description box below. You can download it. Okay, let's continue the topic and let's see some of the problems related properties of determinants. Okay, the last property we have to see is multiplication property. In multiplication property, the multiplication is done with two determinants of same order. That is, I'm taking a determinant with a third order as a del 1 and taking a determinant of del 2 again with the same order. Now let us see how two determinants are multiplied by forming in third determinant. The first row of the determinant is multiplied with the first row of the second determinant as a1, l1, b1, m1 plus c1, n1, and then second element will be formed by a1, l2, b1, m2 plus c1, n2, and the third element will be multiplying first row and the third row as a1, l3 plus b1, m3 plus c1, n3. Okay, the first row is finished. Similarly, second and third row are multiplied and we'll get remaining 6 elements as a2, l1 plus b2, m1 plus c2, n1, and next element as a2, l2 plus b2, m2 plus c2, n2, and the next element as a2, l3 plus b2, m3 plus c2, n3. Now the last row is formed by multiplying the third row of the first determinant with the remaining 3 rows of the second determinant. See, the general form of the determinant value will be in the order of, if the order of the determinant is n, then the resultant order will be also in n only. Now let us see the problems regarding the properties of determinant. Here in this problem, the problem is given as if the determinant is given determinant is equal to 0 in which a, b, c are different. Show that a, b, c is equal to 1. See, this problem comes under the property of fifth. The fifth property states that if each element of the line consists of m terms, that means if each element of the line consists of m terms in the sense, here the column 3 has m number of terms that can be expressed as a sum of m determinants. Let's see how this problem can be solved. Okay. First, we can split the determinant as a, b, c, a square, b square, c square, a cube, b cube, c cube, plus we are separating this m term as a sum of these m terms, right? We'll get as a, b, c, a square, b square, c square, minus 1, and minus 1, right? Now, from the first determinant, we can take the common values as, see, in the first row we can take the common value of a, and the second row we can take the common value of b, and the third row we can take the common value of c. This is the property of fourth, that each element of the line be multiplied by the same factor, then whole determinant is multiplied by that factor, right? By using that property we are taking the common value. So now the determinant will be look like 1, 1, 1, a, b, c, a square, b square and c square. Now we are taking the common value here as minus 1, right? If we take the minus 1 as common, we'll get minus here and the whole determinant would be changed as a, b, c, a square, b square, c square, 1, 1, 1. Now we can use the property by interchanging the lines, right? So we can change a column 3 to a column 1 by using the property of 3. Move to column 1 and regardingly column 1 is moved to column 2 and column 2 is moved to column 3. Now we can say this determinant would look like, that determinant would look like 1, 1, 1, a, b, c and a square, b square, c square by interchanging of lines property. Okay. Now both the determinant are same and they are having a same element. Now we can take that determinant as common, right? 1, 1, 1, a, b, c, a squared, b squared, c squared. While taking the common value, we'll get a, b, c as inside and minus 1. So given in the problem, the given determinant is equal to 0, right? So the solution will be equal to 0. Now, while expanding this determinant, your del won't be equal to 0. Since in the problem they have given a, b, c values are different. Definitely they'll give some numerical value. So del will not be equal to 0. Okay. So that the equation will be put as a, b, c equal to 1. Got it? I hope you can understand this problem. We can move on to the next problem. Now we can solve this problem. Here the problem is given as solve the equations. That is, we have to solve the determinant and we have to find the value of x. See, this is in the form of the property in 7th that if each elements of the line can be added equimultiples of corresponding lines of one or more parallel lines. That means here you can see the row 3. This row 3 can be expressed as some equimultiples of either row 1 or equimultiples of either row 2. Okay. Now let us see how this problem can be solved by using the property 7th. Okay. See, now we can use some mathematical manipulations in the row wise so that we can reduce into the form in which each row or a column can have number of zeros so that the determinant can be expanded very easily, right? Now I am doing some mathematical expansions as in row 3, because row 3 has a maximum number of value. We can cancel it by doing some arithmetic calculation between row 1, row 2 and row 3, right? I am doing as row 3 has been subtracted from summation of row 1 plus row 2, right? So while adding row 1 plus row 2, we'll get 2x plus 2x will get 3x. Then 2 plus 3 will get 5. When subtracting with the row 3, we'll get value this as 0, right? Next, while adding both the row 1 and row 2, we'll get 5x plus 7. And subtracting with this, we'll get 1, right? And while adding both the rows, we'll get in this term as 7x plus 9. By subtracting with this, we'll get as 3x plus 8. Now the remaining rows are kept as it is. 4x plus 5. Now the next operation is row 1 is added with row 3 and row 2 can be given as row 2 minus row 1. By using both the operations, we can reduce the determinant into a following form. Since row 1 is added with row 1 plus row 3. This is a new row 3 we have to add with that. So x plus 2 plus 0 will get at x plus 2 and 2x plus 3 plus 1 will get at 2x plus 4 and we'll get at 6x plus 12 value. And the row 2 is subtracted with row 1 value. We'll get at 2x minus x will get at x. 3 plus 3 minus 2 will get at 1. And we'll get at x plus 1 again. And here also we'll get at x plus 1. Subtracting both the terms. Now the remaining term will be 0, 1 and 3x plus 8. Okay. Now we can take the common value from the row 1 and row 2 as x plus 2 can be taken from the row 1 since it is common for both 3 columns also. First column, second column and third column. We'll get the factor as 1 and we'll get as 2 here and we'll get here as 6. Right? While taking the 6, we'll get 6 into x plus 2. Right? Now taking another common value from row 2, we'll get at x plus 1. 1, 1 and 1. And the remaining value of 0, 1 and 3x plus 8. This determinant can be further reduced into by adding another operation that row 1 is subtracted with row 2. Right? We'll get as x plus 2 into x plus 1, 0. Well, subtracting that as we'll get as 0 and we'll get here as 1 and 5 here, and the remaining terms will retain. Right? Now we can expand by a column 1. Since it has more number of zeros, we can use this column 1 for Laplace expansion. So x plus 2 into x plus 1, this term would be in the minus sign, right? This will be in plus and this will be in plus, so we'll get a minus sign. So minus 1 of this column is omitted and this row is also omitted. We'll get 3x plus 8 minus 5, right? The terms are x plus 2, x plus 1, and the minus has been multiplied. We'll get at minus 3x plus 8 minus 5, we'll get at 3, and we'll get here as minus 3, right? Minus has been multiplied, we'll get at 0. Now the values of terms are, I'll write here. X would be minus 2 and next value would be x is equal to minus 1, and from 3x minus 3 equal to 0 we'll get x is equal to minus 1. So the values of x are minus 2, minus 1 and minus 1 value. Got it? I hope you can understand this problem. Now let us move on to the last problem, that is factorize the fourth order determinant value. This problem could be solved by using the factor theorem, that is sixth property. If an element of a del are functions of x and two parallel lines become identical when x is equal to some value, let x is equal to a, then x minus a is a factor of del. So these are all the elements which have different values, right? There can be a chance where the line, either a row or a column, would be identical. Okay? At that time, your determinant value would come as 0 value while expanding. Right? We can see what role would be the condition. This determinant would be 0. Okay? Now assume, while considering first and second rows, if you assume a is equal to b, that is, if this a is replaced by b, both the rows will be identical, then your determinant value would be 0. So a minus b will be a factor of del, right? Now there may be a condition also in which a would be equal to c also, right? At that time the first row and third row would be identical, your determinant value would be 0. So a minus c will be factor of del, right? And another condition where is a case a can be equal to d also. At that time a row 1 and row 4 would be of identical, right? In that condition your del value will be equal to 0. So a minus d will be a factor of del, right? Now, and similar conditions like b can be equal to c and b can be equal to d and c can be equal to d. At that time all the cases your del value would be equal to 0 and b minus c will be a factor of del and b minus d will also be a factor of del and c minus d will also be a factor of del, right? The highest power of the determinant is 6, so we should have a 6 factors, right? 1, 2, 3, 4, 5, 6 here. So del value would be a factor of a minus b, b minus c, a minus c, a minus d, b minus d and c minus d. We are having 6 factors, right? Represented value for a, b, c, a k be some numerical value. It can be that multiples of your values, right? That multiples of factors. Now for this type of determinants, your determinant value would be in the leading principal value. Your determinant value would be of leading principal diagonal. What is the element in the principal diagonal? A cube, b square, c and 1. So it is of k times a cube, b square, c and 1. We can equate it both, but in this problem they are asking only the factors. So the factors of del r can be represented as a minus b, b minus c, a minus c, a minus d, B minus D, and C minus D. Okay, these are the factors of the determinant given. Okay, I hope you can understand the problems. If you have any doubt, please leave it in the comment section. I'll respond to you. And thanks for watching the video. We can see in the next video.